A warm welcome wherever you may be watching this video from. Uh, Now, a question here from 2020 internal section B, question 2, a question on a chromatography experiment. Okay, the question reads, a learner carried out a chromatography experiment to identify components of substance X. Okay, so this chromatography experiment was all about to identify the components which are in substance X. Okay, a continuation there. Water was used as a solvent. Okay, the results of the experiment are shown in the chromatogram below. Okay, so on the chromatogram here we have substance X. Then we also have the components which were suspected to be in substance X. So these components which were suspected to be in substance X were A, B, and C. Okay, so uh, let's go direct to the question. Yeah, so the first question is there. Which one of the unknown components A, B, or C is insoluble? Okay, so usually what I do is I love explaining so that before I give an answer, somebody may be able to find the answer on their own. Okay, so which one of the unknown components A, B, or C is insoluble in water? So it is not always in water. They can at times they can just say is insoluble. So the solvent is not always water. They can use other solvents. Okay, so from there, which component is insoluble? Okay, so a component that will be insoluble, it is the one which has not moved from the starting line. It is still on the starting line. It has not moved. Then that component we can say it is insoluble. Okay, so as you can see there, B and C, they have moved from the starting line. So here is the starting line, but A has not moved from the starting line. So therefore, A is the one which is insoluble. So there you just say A. Next, the same question, explain your answer. So it's actually what I've already explained. So there you just say uh, why is there? Okay, here they are asking you as in why have you said the A is insoluble? So explain your answer. We are saying it has not moved from the starting line. It has not moved from the starting line. Okay, it has not moved from the starting line. Then we can, it means we have explained as in why A is insoluble. We go to B. Which of the unknown components was or were not contained in substance X? So, which of the unknown components, that is A, B, and C, which of the unknown components were not contained in substance X? So there, we cannot go for A because A is insoluble. We don't know. So, since it is insoluble, we are not going for it. Then we can consider B and C. Okay. Now the question is, how can we know that this substance is not contained in a certain substance like substance X? Okay, this is how we can know. A substance which has not moved the same distance as substance X, then we can say it was not contained in X. So from there, from the substances which have moved, we have B and C. So on B and C, there is one which has not moved the same distance as X, as substance X, meaning that substance is not contained in substance X, or meaning that component is not contained in substance X. So from there, B has moved the same distance that which substance X has moved, and then C, it has not moved the same distance as substance X. Therefore, component C was not contained in substance X. So you just say C unless they say explain. So B, it is just C. Or if you want, you can say component C. Okay. Then that is B that we have answered. Then we go to C. Calculate the retention factor, RF, meaning retention factor value for component B. Okay, so we have seen the distance that B has moved from the starting line to how far X has also moved from the starting line to there. Okay, so there is a formula that we use in order for us to calculate for retention factor. Okay, so here's the formula. We say RF, retention factor value, is equal to RF is equal to the distance moved by the spot over the distance moved by the solvent flange. Okay, so on top there, I hope we can see where they have labeled solvent flange, meaning this is how far the solvent moved. In this case, this is how far the water moved. Okay, but the spots, they moved from the starting line, like for beats, from the starting line up to here. Okay, so without wasting much of our time, we are saying retention factor is equal to distance moved by the spot over distance moved by the solvent flange. Okay, so from here, how can we get the distance moved by the spot? Okay, first of all, we have been given 28 centimeters, which is the distance moved by the solvent flange. So from the starting line to the solvent flange here, we have been told that it is 28 centimeters. And now, from how far a component B has moved, here up to the solvent flange, we have been told that it is 7 centimeters. So for us to get, so you can write that formula which I was shouting first. So for us to get the distance moved by the spot for component B, which they have mentioned here, we need to know this distance from B here up to here, because that is how far this component B has moved. Now, how are we going to get that figure there? Okay, we know from the starting line to the solvent flange it is 28, and then from here to the solvent flange it is 7 centimeters. So in order for us to know the distance from the starting line to how far this component B has moved, then we can say 28 centimeter minus 7 centimeter. It means we'll get the distance that component B has moved. Okay, so 28 minus 7, which is 21 centimeter, meaning component B has moved 21 centimeters. Okay, so we have the distance for which component B has moved. Okay, next we need the distance moved by the solvent flange. So the solvent flange moved from the starting line up to where they have indicated here as the solvent flange, which is 28 centimeters. So therefore, we can say RF, which is retention factor, is equal to distance moved by the spot over distance moved by the solvent flange. So the distance moved by the spot is 21 centimeters, then divided by the distance moved by the solvent flange, which is 28 centimeters. So if you divide 21, let's go to our calculator. So if we say 21 divide 28, so 21 divide 28, it will give us 0.75. So our retention factor, our RF, is 0.75. Okay, so thank you for watching this exciting video. Be sure to subscribe to the channel and invite more of your friends to subscribe to the channel. Thank you for your time. Stay blessed.